Welcome to the presentation on Medicare Healthcare Management System Database Design. This session is part of our Data and Information Management course, Assignment 2. Today, we will explore the structure, functionality, and design principles essential for building an efficient database system tailored to manage healthcare data effectively. The purpose of this project is to design and implement a database tailored to streamline Medicare's operations. Our goals are to enhance efficiency, reduce manual errors, and create a seamless management system. Key focus areas include managing patients, doctors, appointments, payments, and staff effectively. Let's delve into how we plan to achieve these objectives. Moving on, we have identified five main entities crucial to our system: patients, doctors, appointments, payments, and staff. Let me explain each one briefly, highlighting the importance of the information we need to capture. For patients, we capture details like patient ID, name, date of birth, gender, address, and contact number. This information is essential for personalized care and communication. For doctors, we identify the doctor ID with additional attributes like name, specialization, and experience. This data ensures appropriate patient-doctor assignments. Next, for appointments, this entity connects patients and doctors using foreign keys. It includes an appointment ID, date, and time, enabling efficient scheduling and record keeping. For payments, we track by a payment ID and link to appointments. We record the data to manage finances and ensure transparency. Staff details include staff ID, name, role, and assignment status, helping to manage hospital operations and staff allocation. These entities and attributes provide a comprehensive structure to manage our healthcare system efficiently.
Thank you, Dion. When you talk about functional dependencies are essential in database design. As we define the relationship between attributes in a table, for instance, in the patient's table, the unique patient ID determine the name, date of birth, gender, address, and contact number. Similarly, in the doctor's table, the ID identifies the name, specialization, experience, and availability. By establishing these dependencies, we ensure data consistency and integrity, which is critical for reliable healthcare management system like Medicare. And when you talk about normalization, normalization is a process of structuring data ways to minimize redundancy and ensure data integrity. In our design, we apply normalization tools to achieve one normal form, two normal form, and three normal form. For example, splitting data into related tables ensures that each piece of information is stored only once, making updates more efficient and reducing errors. This process is vital for Medicare to handle complex data effectively, improving the overall system performance and reliability. And now I invite Ismi to continue the presentation.
Thank you, Shamika. I'm Samita Jaisena. This is the entity relationship diagram for our Medicare healthcare management system. It visually represents the structure of the database, including entities, their attributes, and relationship between using crossword notation. Here we have the patient entity with attributes like patient ID, name, and contact number. It stores all necessary patient information. Similarly, the doctor's entity stores doctor-specific details such as doctor ID, specialization, and availability. The patient entity has a one-to-many relationship with appointments, as a patient can have multiple appointments, but an appointment is linked to only one patient. The appointments entity has a one-to-one relationship with payments, as each appointment generates a single payment. The relationship between staff and appointments is many to many, so we introduce an associative entity called staff assignment to manage this. Overall, this ER diagram provides a clear and efficient structure for managing Medicare database. We implement the database in SQLite using the ER diagram as a guide. This is our creation queries. Key features, primary and foreign keys, data types, and relationship enforced via constraint. We added sample data to test the database. This is our screenshot for tables. In summary, the ER diagram guided our database implementation and populate tables confirm that the system works as expected. I'll now pass it on to Sami to continue with the presentation. Thank you.
Hi everyone, I'm Yesidi Ranatunga and today I'm going to explain you about the advantages we can get from the query designing and some learnings we got from our assignment. So first of all, I would like to explain some advantages we got and mainly the purpose of these query designing. So after creating the database and by creating queries, we have to we should extract meaningful data from those database. That's the basic and main purpose from the query designing. And as an example, as you can see in the slides also, it's mainly example is mainly based on the queries of Medicare system we did, and from these queries we can get the all doctors information, all like unpaid bills and everything. So if I explain you one by one, it means like retrieve all appointments for a specific doctor. We can track their details and who are the who's the doctor and very specific details from those queries, and also show payment details for a specific range of data range or date range, and also list of all members assigned to a specific appointment. And also we can check whether the patients have been paid or if there are any unpaid bills from patients as well. And so finally, I would like to explain you some key learnings we understood from this assignment. There are some key main three learnings. So one is the main importance of database normalization, because actually normalization helps us to simplify the complex data sets, and to simplify those complex data sets we need normalization, and also normalization reduce the data redundancy, and it increase the data quality and data integrity as well. So we thoroughly understood the basic importance of these database normalization from this assignment, and also how to enforce data integrity using some foreign keys as I explained you earlier, and also writing efficient SQL queries in order to get meaningful insights and meaningful data from the design databases. And thank you.